In Activity 9, Creating a Cloud, students first discuss how clouds form, then deliberate a cloud's contribution to weather, and finally construct cloud chambers and create clouds in them. You will need the following materials from the kit: Activity Sheet 9, plastic tumblers with lid, sheets of 45 by 60 centimeter black construction paper, box of wooden matches, and weather stations. You will also need to provide weather reports, bucket or bowl to hold ice, flashlight, and warm tap water. To prepare for the activity, make a copy of Activity Sheet 9 for each student. You will need to collect weather reports. This activity requires that the teacher drop a lit match into each team's tumbler of water. Make sure to closely supervise this step of the cloud chamber activity. Cut each sheet of black construction paper into 9 5 centimeters by 7.5 centimeters rectangles. Obtain crushed ice or very small ice cubes. Each team of 2 will need a tumbler, a lid, access to the ice and warm tap water, a rectangle of black construction paper, and their weather station. Begin the activity by asking students, where do rain and snow come from? Accept all reasonable answers. Explain that all precipitation that falls to the earth begins its downward journey from clouds. Then ask, if rain and snow fall from clouds, where do you think clouds come from? Students may or may not know the answer to this. Explain to students that the sun heats the surface of the earth, causing water to evaporate and rise into the atmosphere. Convection occurs when warm air rises and cool air sinks to take its place. This cool air, in turn, is heated by contact with the warm earth, so it rises, cools, sinks, and the cycle repeats. Warm air contains water vapors. As the air rises, the water vapor in it cools. When water vapor cools and touches a surface, it turns into liquid water. This is called condensation. Next, explain that small airborne particles of material, such as dust or smoke, called nuclei, are present in the air. These tiny airborne particles provide the surfaces on which the water vapor can touch in order to condense. The condensed droplets of water gather around these particles and form clouds. As temperatures get warmer on the surface of the earth, more water evaporates, causing more warm air to rise and cool. Therefore, more water vapor condenses and a bigger cloud grows. Distribute Activity Sheet 9 and instruct students to come to the distribution station, fill a tumbler with warm water, put some ice on top of a lid, and then return to their work area. Ask students, which stage of cloud formation does this procedure simulate? This simulates the process of making moisture-laden warm air. Have the teams pour out all but 2.5 centimeters of the water in the tumbler, and then quickly place the lid with ice on top of the tumbler. Then ask, which stage of cloud formation does this procedure simulate? This procedure simulates the cooling of the water vapor, which would happen at higher altitudes. Remind students that the water vapor needs something to condense on. Although it can condense on the sides of the tumbler and the underside of the lid, this will not form a cloud. A cloud is tiny drops of liquid suspended in the air, not tiny drops of liquid coating a large surface. Ask teams to hold the black sheet of paper against the back side of the tumbler. Drop a lit match into each team's tumbler. Be sure that the lid is opened only slightly to make room for the match and then closed immediately. Exercise extreme caution when using matches in the classroom. Ask students, which stage of cloud formation does this procedure simulate? The smoke from the match provides the nuclei on which the water vapor can condense. As soon as the match is dropped into the tumbler, students should observe what is happening inside the tumbler. If teams have difficulty seeing the cloud, try shining a flashlight through the tumbler while they observe. Remind them to record their observations on their activity sheets. Next, ask, where might you expect to see more clouds forming, over a lake or a desert? Students should infer that more water is available to evaporate from a lake than from a desert. Therefore, clouds are more likely to condense and form over a lake than over a desert. Have the students retrieve their weather stations and secure their newest weather report on top of the other reports in the bottom center of the weather station. Finally, lead a discussion comparing yesterday's forecast with today's actual weather. To conclude the activity, discard the water, ice, and the used matches. Have students return the tumblers, lids, and pieces of black paper to the kit and their weather stations to the designated areas. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.